Hi, thank you for joining us today for Aspire's Ask the Expert session, IoT edition. I'm Cody Harris, Director of Digital Architectures here at Aspire Technology Partners.
Hi, I'm Kyle Turk. I'm a technical solutions architect in emerging technologies.
Hi, I'm Keith Heckle, pre-sales solutions engineer in emerging technology.
Topic for today is CURWB, or formerly known as Fluid Mesh. So, what's CURWB?
CURWB is what Cisco rebranded as Cisco Ultra-Reliable Wireless Backhaul. I know that's
It's a mouthful.
It's very hard to say. But basically what it is, it's a bridging technology that is also highly available. So we see this deployed mainly in IoT spaces, but you can also see it deployed elsewhere at schools, higher ed, whatever it may be. You can utilize it as basically a wireless bridge link that's super low latency. So it allows you to get high definition video, any applications that require low latency across the network over a wireless bridge where it's really hard to run fiber is where you'll see it. Ideally, I believe it also runs on its own proprietary protocol over a certain band, not mistaken, right, cost.
Yeah.
So it's not running or it's not interfering really with anything else that you're doing. If you're at like a, I don't know, seaport, right? You have multiple different fluid mesh access points or antennas set up, and then you have an autonomous cart driving down a road, right? If one of those antennas were to go out, it's automatically going to go to another access point. Or antenna.
Right.
So that's the highly available part. If one of these were to go down, or even if it's up, it's going to find the best possible path for it to send its data, so that you can make sure that your inventory is getting where it needs to go, and it's going to get there on time.
Interesting. Yeah. So I think if I remember correctly, that part of the fluid mesh value was in the roaming technology, right? That weren't they installing these on high-speed trains, right, to provide Wi-Fi access?
It's highly available. It's based on an MPLS technology. So really the magic is about that high availability, high redundancy, fault tolerance capabilities, and high roaming. Roaming fast enough from AP to AP on a high-speed train, driving down the road, or in a port. That's really the key where this shines. It's not about distance, it's about availability. And are these nodes available to me if I go down, and how does the traffic get over there, and the QoS and all that, and making sure that all the traffic that needs to get there gets there in a speedy and timely fashion.
Interesting. So if you had multiple devices connected via mesh, it would be able to kind of analyze the links, determine what the best link is, send the traffic over the best possible link, or to do fault tolerance if the link goes down.
Yeah, very similar to an MPLS tag network.
Right. Interesting.
Or
Okay.
switch network.
Interesting. So let's say from a business perspective, I'm a C-level manager, right? What's the value proposition I'm going to see out of a technology like CURWB?
Owning your own WAN, delivering security and high speed connectivity, and ultimate redundancy and capabilities.
Yeah, everyone looks towards what is it, 5 nines, so 99.9%
Right, sure.
available. That's
We're
pretty
used
much
to
what-
it, but
Yeah, that's pretty much what you're getting with fluid mesh or CURWB, sorry. And basically, like we keep alluding, it's the MPLS, it's all the QoS. It's going to basically take the best possible route, no matter where it is, and use that route, even if one is down. So it's really the reliability of it.
Now, does this also apply to the access layer, or is this strictly like a backhaul layer technology? I mean, are users connecting to?
yeah,
Users
no,
are
the
connecting, right?
users do not connect to this
Right.
since it's not a Wi-Fi standard,
Right. Okay.
and it's only for backhaul
Right.
and redundancy. So you put multiple links up, and you have redundancy in that fashion.
Interesting.
You connect your buildings without having to connect them traditionally. When you can't, or when you don't have the money, or you don't have the infrastructure to do so.
Sure.
Yeah. Ideally, what we do, I mean, we've seen everything from as simple as 2 bridge links with video hanging off one side just for security cameras,
Sure.
to, like you said before, where we have it installed on high-speed trains and we're providing wireless on board to passengers.
Right.
So it could really be, it's very flexible and it can really be deployed anywhere.
Okay. What kind of bandwidth are we seeing on these devices?
The maximum throughput is usually 500 megabits,
500
and that's a
okay.
licensed feature.
Okay.
You buy the product, and then you license the features that you need. If you only need a 10 or 100 megabit link, you buy the 100 megs that you need. If you
Gotcha.
need VLAN tagging, you buy that license. You need highly advanced AES encryption, you buy that license. So
Okay.
that's kind of how it's designed.
So there's a lot of layers and add-ons.
Yeah, it's like, ordering a pizza.
Right. You can have the sardines, you can
Yeah.
have the pepperoni.
Anchovies, yeah.
Copy that. Okay. And so it sounds like really, if you're interested in this is something that you're going to need an expert to come in and make sure that it's deployed correctly, that it's designed correctly, and that it's scoped out correctly, and you have all the proper licensing and all the things you would need, right?
Yeah, I think a very important piece of a project like this
Mm-hmm.
is designing, understanding what your environment's about, doing a survey, because these devices exist in an ISM band
Mm-hmm.
that's available to the general public and any entity out there right now. So
Yeah.
there's a lot of capabilities, but you just have to make sure you know where you can play.
Mm-hmm.
Right. Or the biggest part of it would be the surveying. So
Right.
on the actual devices, they have lights that'll show you how much the signal strength is. It'll go from like red to green.
Mm-hmm.
That's also not really indicative of the signal strength that you're actually getting.
Okay.
So within CURWB, there's what they call Racer, which is its cloud management platform. And you can log in and you can actually see what it's getting real time as far as the signal strength goes.
Copy that.
We can also
Okay.
read that with Heckle. We do a lot of site surveying with Heckle.
Sure.
So that'll tell us where we actually really need to point antennas.
Yeah.
If we need to move it 10 degrees to the right or 10 degrees to the left, wherever it may be.
Right.
And that's really where the value add comes,
Mm-hmm.
is the whole surveying and getting the design right from the beginning and not kind of just spitball.
Yeah, throwing it out there and then having to adjust and fix or whatever, right? So yeah, so look, it's good for us because we have a ton of experience in that area, right? I mean, Turk, how long have you been doing site surveys?
Long time,
Right? I mean, I've been doing them 10 years. You probably what, 15,
25.
25? Yeah. So a lot of experience in that area. Now in terms of use cases, I mean, maybe what are some of the specific use cases that we would see where fluid mesh or CURWB would be a good application?
WAN links. You have a spot where you have things being stolen, you put a video camera up, you connect your video camera to this thing, and then fluid mesh connects it back to the core. That's another great example.
Mm-hmm.
Any outdoor uncarpeted space is really a potential for this.
Okay.
A lot of it could be worker safety as well. So using autonomous vehicles, you can essentially have a camera running on a vehicle and a worker at a remote location,
Mm-hmm.
and you can have a fluid mesh link, curb link between them two,
Mm-hmm.
and you can have a worker working on that vehicle real time while
Right.
not being in harm's way.
Right. Okay. Now I've heard that there's an opportunity to deploy CURWB for a cruise line local to us. That sounded super cool to me.
Yeah, there are more advanced capabilities and features that you can implement, especially when you get more advanced antenna systems.
Mm-hmm.
We're deploying a system made by a company that allows you to track the motion and the alignment of the antenna while the antenna is in motion.
Yeah.
So these can then be used in use cases like on ships traversing from the shore to an oil rig.
Mm.
You don't have connectivity, but you need to send data back and forth between either one of those locations
Right.
or both.
Right.
That would be a use case for these highly automated antenna systems.
Hmm.
So it adds a lot more capabilities because then you can deploy these on moving things.
Right.
And
Right.
they can stay in contact, like a forklift or a boat
Mm.
or a ship
Mm-hmm.
or a car or a train.
Right. So I could see good applications within the warehouse and manufacturing, which is an area we play really well in. But I'm interested. So how is this antenna system actually tracking the boat? I mean, is it doing it is it sensing the RF?
Yeah.
And it's adjusting to what it sees as the
Mhm.
strongest signal? Okay.
Yeah. So this antenna has the ability to sense
Yeah.
the signal and then adjust servos to point and align it to where it needs to be.
Mm. Okay.
Very advanced.
So as a boat goes up the river or the ocean or whatever it is, these antennas are moving with it to make sure that the
That's exactly it.
signal strength is strong, the connection is strong.
Yeah, and some of the ones that they make are electrically driven, and some of them are physically driven by the antenna array.
Mhm,
So
mhm.
you've got some that are logically moved
Mhm.
and some that are physically moved.
And this particular one is to affect Wi-Fi access on the boats, right? Is that right?
Right. So
Yeah,
we have
yeah.
basically our whole network hanging off of fluid mesh link. One's existing on the dock, the other is going to be existing on the switch.
Yep.
Or on the ship, sorry.
Right.
And from there, we have a network sitting there that's going to provide wireless access to the customers. It's going to allow internal access for employees and whatnot.
Okay.
So that's pretty much the design we have going on there.
Yeah, that's interesting. Although to your point, it could be used to capture data or, other
Oh, yeah.
sensor data or other stuff as well.
Location,
Yeah.
whatever.
Okay.
else you may need.
Okay, cool. Awesome. Thank you guys very much for your time today. It was very informative. Very informative chat about CURWB. So for everybody else, look out for future topics on IoT and other solutions within the Aspire toolset.